Hello, everyone. So yet again, welcome to Programmers Week, Cognizant Vision's largest annual technical event. Thank you for joining. Today, we will be talking about building your own jetpack. So let's get some things out of the way. First of all, I'm Radu. This is Alex. We are both senior Android developers here at Cognizant Vision for, about 5 years now and doing Android for more than 8-9 years. And we're both big Rick and Morty fans. What we are not is aeronautical engineers. So you can imagine building an actual jetpack was not easy. Needless to say, there were 3 of us when we started the presentation. And if you've seen episode 4, season 3, you know it does not work out for Vance Maximus. Okay, so let's stick with what we know, and that's Android. So today we will be talking about the Android Jetpack. The Android Jetpack is a set of libraries released in 2018 when finally Google replied to all of the problems that developers were talking about on all forums and Stack Overflow and whatnot. So they came in with this large set of libraries that keeps on growing and has awesome stuff in it. So if you haven't taken a look, you should start looking at it because it's got a lot of things and many more than we actually printed here on the screen. And since it's so big, today we're only going to be talking about ViewModel. So this is a presentation out of a series that we want to present. Now, when we talk about ViewModel, myself, I'm going to talk about what a ViewModel is and how you can construct your own. And Alex is going to continue with how you should or should not be using ViewModels. Okay, so let's see. What is a Jetpack ViewModel? So if we look at the basic definition from the documentation, it's an in-memory data store that serves data to your UI, and it doesn't need to care about configuration changes. It is lifecycle aware. Your view should be dumb, and it should only be using data served by the ViewModel, right? So let's look at an example. We have a My ViewModel. We just extend the ViewModel class, right? Easy peasy lemon squeezy. We have a live data exposed to the outside world. If you haven't used it before, this is basically just a simple observable pattern that's lifecycle aware. So you don't need to worry about disposing it. Now, I don't know if you've seen this pattern before with underscore users. This is called a backing property idiom, right? So what it does, it's a form of encapsulation where you keep your data internally in your class mutable, but you expose it to the outside world as immutable. Cool. Now let's see how we actually use it. In your view, you just get a reference to your view model and you use this very nice delegation pattern by view models. This means that it will construct a view model, tie it to your activity, and then you just use whatever needs to be used from it. You observe that live data and you update your UI. So it's pretty easy. Now, if we look at a second example, this is actually a nice side effect. You can actually share data between fragments by using a view model through the activity, right? So let's take a simple master details pane example where you want the master pane to select an item from the list and the detail pane to show details about that item. So your shared view model should actually be controlling what's selected on the screen, right? Now, in your master fragment, you're going to show that list, right? You look at that list, and whenever the user clicks on it, you get this item selector on click listener activated. And then you just go to the model and select that item, mark it as selected. Then on the detail side, you just get a reference to your view model using the activity. It's super important here and in the master fragment that you obtain a view model using the activity. So that shared element between these two fragments, right? That shared lifecycle owner. And in the detail fragment, you just observe what's selected and update your UI accordingly. So sharing data between fragments has never been easier. And this is done through view models shared through an activity between the two fragments, right? But really now, why do we need it? So up until now, we've seen things that we could do without Jetpack ViewModel. Somehow, we'll see the subtle nuances there. So first, we need to go back to the basics. When an activity gets created, you have its life cycle, right? So first, you know it's getting created, then it's becoming visible, and then it's getting the focus. What happens when we rotate the screen? It loses focus, it loses visibility, and gets destroyed. Weird. Then gets created again, becomes visible, and becomes focused again. And then when we finally press that back button or finish it programmatically, it gets completely destroyed. So loses focus, visibility, and gets wiped out. And the problem here is when during an activity rotation, it actually destroys and recreates a new instance of your activity. You're getting two completely different instances of that activity. Why this happens? Ask Google. Basically, you can have different layouts based on portrait versus landscape. And you can have different views in it. So Google said, hey, I'm not going to leave that responsibility to developers to actually do due diligence when it comes to memory. So I'm going to force them to do it by recreating their activity altogether. But what's the problem when we have two instances? All of the data that we captured up until we started rotating the activity is going to get lost. New object, new data, right? Everything we had gets lost. How do we fix this? Well, we do have that save instance state, but you can only add few items in it, nothing dynamic. You can't add a socket there if you need it. So you kind of lose a lot of things. So here is where the view model comes in. When you bind the view model to an activity or a fragment, it's actually gonna live and survive configuration changes and go away at the point where you don't need it anymore because the lifecycle owner is going completely away, and you get this nice callback here. So wow, right? This is awesome. This is what we've been wanting for so many years, because I think if you look back before the Jetpack ViewModel got in Android, I think more than 90% of the apps were fixing this problem by blocking applications in portrait mode. Who needs landscape anyway, right? Now let's see how this magic actually happens. So what APIs does Google expose to us? So if you look at the ViewModel class, is just an abstract class, right? No abstract methods, no whatever, nothing, no fields. You just need to inherit from it, right? This is why it's called an abstract class. And then you have an uncleared method. You can decide whether you want to override it or not based on your use case. Do you have any resources that need to be released? Then overwrite it and release them. If not, don't worry about it, right? So what is this magic? Because it doesn't tell us anything. It's super simple. However, it does a lot of magic for us. So personally, I don't really believe that Google does magic. And I don't believe that they did something incredible and made it out of thin air. So what I want to do is actually learn how to build it myself, right? And we all are going to learn how to build it ourselves. So let's see a set of requirements for building our own view model. So first of all, like numero uno, we want our view model to survive configuration changes, right? To maintain that state and not lose data during configuration changes. Second of all, we want a view model to be able to tie to a certain view, let's say, a fragment or an activity, a lifecycle owner, to which it's going to serve that data. And third of all, when we don't need a view model anymore because the lifecycle owner is gone, we want to be able to release resources, right? We want to be able to clear our view model. So to be able to actually understand how to do that, we're going to go back to the basics. So first of all, we're going to create a lifecycle logger, which is a lifecycle observer. By the way, this is also part of Jetpack, is the lifecycle library there. And what this object does, using this very nice annotation, is we're going to register it on lifecycles to receive every event there, right? And we're going to log it to logcat, and we're just going to observe what happens. So going back to a super simple activity, we just go and add our observer to the lifecycle and remove it when it's not needed anymore, right? So let's see what happens. When we first create the activity, right, the user launches it from the launcher, it's going to get created, it's going to become visible, and then it's going to get focus. The moment when we rotate the screen, it's exactly what we talked about. It gets destroyed and recreated, right? So it loses focus, visibility gets destroyed, creates a completely new instance, becomes visible and focused, and when we don't need it anymore, it goes away, right? Loses focus, visibility, and altogether garbage collected. Cool. Let's add a fragment in this mix. And for this fragment, we're also going to register a lifecycle observer and see what happens, right? So in our activity, we just go and add our fragment to the activity if it hasn't been added before. So this, don't ever forget about this check, because this tells us if it's the first time when we're creating the activity or it's been rotated, right? So only add your fragment if it hasn't been added before. Okay, and we're gonna see what happens to the lifecycle. So when we first create that activity, the activity and the fragment are in tandem, right? Activity gets created, fragment gets created. Fragment becomes visible, so does the activity, and then the activity and the fragment become focused. They gain the user's focus. Let's see what happens when we rotate the screen. They both lose focus, they both lose visibility, and they both get destroyed. And guess what? They both get recreated. And we do see different instances when they get recreated. Look at the activity here, and the fragment here and here. Now, two things that are important here. The fragment lifecycle is strongly coupled with the activity lifecycle, and you can see it here. It always happens in a sequence. So if you're curious, when does the fragment's on resume get called versus the activity's on resume get called? The answer is easy. When in an activity you do that super.on resume. That's when all the fragments that are attached to that activity get their on resume called as well, right? Second interesting tidbit is if you have a fragment added to an activity, it's gonna recreate it when it gets recreated. So that's awesome. It manages that fragment stack for us. Cool. And when it gets destroyed, of course, they're both in tandem. Both the activity lose focus, lose visibility, and get destroyed. Now let's add another fragment to the mix, because it was too easy up until now. Another fragment that we're going to observe its life cycle. And what we're going to be doing is grabbing the fragment manager. So let's say when you do an on click on the screen, it's going to replace the current fragment with the second fragment and add the first fragment to the backstack, right? We just mentioned an activity has a stack of fragments, so it's able to actually manage it. And you're the one that decides whether something needs to go on the stack or not. And now let's see when we start the activity. It gets created, so does the first fragment. They gain visibility, they gain focus, right? Afterwards, we press that button, so the second fragment gets created. The first fragment loses focus and visibility because it gets replaced by the second fragment, which gets visible and focused. Cool. Let's see what happens when we rotate the screen now. So yet again, main activity gets paused, second fragment gets paused, so they lose focus, then they lose visibility, and then all three of them get destroyed. Don't forget that the last step, when you replace the first fragment, it lost visibility and focus, so now it doesn't anymore, but it still gets destroyed, right? And then we see the recreation. So what happens here is pretty interesting. The activity gets created, and now not the second fragment, but the first fragment gets created and becomes visible. Then the activity becomes visible and focused, and the first fragment becomes focused. But what do we see then? The second fragment also gets created. It replaces the first fragment, and now it's the one that's visible and focused. So what conclusion can we actually draw from this? So the activity is super smart when it's recreating its fragment stack, because it's actually going to create it in the causal order it was initially created. So it makes sure that everything is still on the screen in the order that it was added in portrait. Now, when you're in landscape, right? And it actually passes all of these fragments through the life cycle. So they've had a clean pass, they've drawn their UI, and now they're in the exact order you left them before you actually started the rotation, right? And of course, when you're going to be pressing back, you're going to need 2 back clicks this time because you've got a backstack, right? The first click is going to kill the second fragment, right? So it's going to lose focus, lose visibility, and get destroyed. And the first fragment now gets back the visibility and focus. And the second back click is going to destroy the activity and fragment through the destruction lifecycle. Cool. So now let's do something that may seem weird. So I call it fragmentception. I don't know if you know this, but you can actually add a fragment inside of another fragment. So not necessarily inside of an activity, right? So we're going to add this incepted fragment, which is also going to have its lifecycle observed. So let's see what happens for the first fragment. When it gets created, we're gonna ask to replace a frame inside this fragment with the incepted fragment. But be very careful. I'm not using the fragment manager here. I'm using the child fragment manager. And this is super important. If an activity has a backstack, a fragment backstack, now imagine that every fragment has its own fragment backstack. If you want to affect the activities fragment backstack, you need to use the fragment manager. If you want to affect the fragments fragment backstack, you're gonna need to use the child fragment manager. And I can't stress this enough because I've seen a lot of cases, a lot of bugs coming in from production where people were using the wrong fragment manager when doing this, right? So remember the rule. Inside an activity, use fragment manager. Inside of a fragment, use child fragment manager. If you don't do that, you're gonna mess up your backstacks. And now let's see what happens. So when we first create this activity, it's gonna get created along with the first fragment, become visible and focused, and then it's gonna create that incepted fragment automatically and take it through the life cycle up until it's focused. So notice how the incepted fragment does not replace the first fragment. They're both visible, they're both focused right now, okay? Let's see what happens when we rotate. This is the interesting part. So the activity is on pause, incepted fragment on pause, and first fragment on pause. So if you look at it, it's actually destroying and recreating all of them because they were all visible on the screen. So this means that not only does the activity backstack get recreated, but the fragment backstack also gets recreated. So you get all of that nice thing, all of those nice things that we saw in the other case, also here. When you destroy them, again, they're all in tandem. So they all lose focus, all lose visibility, all get destroyed. Awesome. But up until now, we've just figured out how the backstacks work and how fragments work. But we're gonna see, we still haven't seen how to actually build a view model, right? So in comes a nice little tidbit. A thing that's been in the documentation for some time, very poorly documented, and nobody actually talks about it a lot. So it's the retain instance that you can set on a fragment, right? Making it a retained fragment. I'm not gonna go into the documentation. Let's directly look at empirical results and see what it does, right? So we're gonna be just creating a simple activity that contains a retained fragment, nothing too fancy. What do we see? The same as before. Activity gets created, fragment does too. Fragment gets visible, activity does too, and they both get focus. Awesome. Now let's see what happens during the activity rotation. Activity gets paused, retained fragment gets paused. Activity loses visibility, fragment loses visibility. Activity gets destroyed, fragment gets up. Nope, it does not get destroyed. Activity is created, fragment is not recreated. But then what do we see? The activity is started and the fragment is started. And the activity is resumed and the fragment is resumed. So the first conclusion we draw is that when you rotate the screen with a retained fragment, it's gonna go through the life cycle, but not completely. It's not gonna get destroyed and recreated, but it still goes through the rest of the life cycle. So if you look at the documentation, it actually states it's gonna get attached and detached from the screen, the activity or the fragment, but it's never gonna get destroyed and recreated. And you can actually see that although the activity has a different reference, the retained fragment has the same reference, right? Cool. What happens when we press back? The activity and fragment, they both lose focus, lose visibility, and both get destroyed. So at this point, only at this moment in time does the retained fragment get destroyed. So I think we're all starting to see a pattern here. So what could actually be used to build a view model, right? So let's take all of our requirements one by one. A view model must maintain state across configuration changes. Cool. Use a retained fragment. We just saw that it does exactly that. It's the same instance. A view model must be able to bind to activities. Then you use the fragment manager. What about when we want to bind to fragments? We just saw we use the child fragment manager. So we affect different stacks. So we gain this possibility of binding to different lifecycle owners, and we still get to keep this beauty of maintaining state across configuration changes. And the last one is a view model must be cleared when lifecycle owner is finally destroyed. So what do? we actually override the retained fragments on destroy. And that's it. We basically saw how we can recreate the behavior from the Jetpack ViewModel using simple things, right? So one eternity later, we finally reach a conclusion that it's actually possible to do it without magic. I'm sorry, people, magic does not exist. If you want to learn how things are done, just go to the fundamentals and understand what's going on there, right? So for the next part, I'm going to stop sharing and I'm going to let Alex do the talking because I've been talking way too much up until now. Thank you. Alex, you have the floor.
Okay. So, yeah, let's see now. We've seen some interesting things about Jetpack ViewModel. So let's switch to the other perspective, and actually talk a bit about how we can actually use them from the views perspective. Generally speaking, the view is a very lightweight component that's designed to always reflect whatever state is stored in our view model. It does not have to concern itself with any configuration change, and therefore it should be very easily recreated whenever needed. And similarly to the view model, we can make a few assumptions on this side as well. First of all, we should never care if or when our view is destroyed. We should be able to observe data from any view model instance, regardless of its life cycle. And it should never ever store any state under any form it may be, because you're gonna see state can take multiple forms. And let's recap on a previous example where we make a small mistake and we don't actually use the factory methods that are provided in the Jetpack framework. In this example, we are instantiating manually a view model. What we've easily done is we've created a component that lives just as long as our view does. And as we always, we don't actually use the required factory methods. And we always lose reference to it upon a configuration change. Furthermore, we've lost the ability to handle uncleared, which Radu said is important that it is, because this is where we dispose of any precious resources we previously held. And after all that, it's now the view's responsibility again as its owner to clear of clearing them, and we've accomplished nothing. And the same issue, but in a more advanced scenario, would be represented by trying to build a sort of composite view model scenario. Just by looking at this piece of code, we can assume that the other view model hasn't been, I don't know, designed and cannot be a proper Jetpack view model. Why? Because exactly as in the previous example, we get into the ownership issue. We can't be sure of what component maintains a reference to that view model and who is actually responsible of calling its own clear function. Because the view model is an effect, theoretically, of the view using the appropriate Jetpack factory functions, we can safely assume that the other view model was obtained in the same fashion. Therefore, the only logical conclusion is that we use the view to obtain its instance somewhere on the dependency chain. And that leads to inevitably, shortening the life cycle of our current view model and making it the same length as the view's life cycle, because that's the maximum that we can be sure of. To be more specific, the received view model instance can have a shorter or longer lifetime. If the current view model is, a fragment bound view model, it can be, the received view model can be actually be longer. In both cases presenting different issues. But yeah, we can make assumptions and trust our developer skills that we will never ever use different life cycles for the two view models. We still have the issues with injecting the view in the dependency chain, but we cannot make sure that these rules are upheld in the future, as future maintainers will work on this piece of code. And actually, a much more easier and verbose solution, I like verbosity. It's very good for feature maintaining. Would be to binding the correct instance in the view. So in this scenario, we bind the two ViewModel instances directly in the view, and we can see that the two have different lifecycle lengths. And we manually route the necessary actions whenever necessary. This is a couple of lines of code maximum, and we have now established that the view is a kind of bridge between all the view models that we bind to. We actually don't care how long they live and how long when they'll be cleared. We know that this will happen because we've used the appropriate Jetpack factory functions. And we know that this won't happen while we're still bound to them and we need to use the resources because this is the main issue. The owner of the instances is now the same ViewModel store Radu was designing in the first part, and we are using everything correctly. Okay. And going back to those assumptions, maybe a more interesting topic would be the importance of not storing anything inside our view. We should always just reflect everything the ViewModel says and whatever state we receive from the ViewModel via live data. To better see this, the importance of this statement, we can take I know the Jetpack navigation framework as a case study. We're not going to go through what it accomplishes or offers to us. We'll just treat it like a simple navigator, albeit one that has a few quirks and it's sometimes weird in its behavior. So on one side, as we've seen previously, navigating away from an activity is pretty straightforward. The previous activity is stopped, the new one is resumed, just like you'd expect. Each goes through the corresponding lifecycle methods. Navigating with fragments and Jetpack navigation is very similar, with the exception of a slightly more complex lifecycle. The idea is the same, though, where the new fragment is created from scratch, it goes through its lifecycle, and the previous one reaches the stopped state. Popping the backstack in the activity scenario is again straightforward. The actions are actually just reversed, and the previous activity is started and resumed again, while the one we're exiting is going to be destroyed. What happens with fragments, though, and Jetpack navigation? At least they seem tidy, but there is one big difference. The previous fragment somehow goes through all its lifecycle again. And depending on how we wrote our fragment, or rather the amount of assumptions we made in our fragment, this can have a big impact. I haven't properly shown this here, but this is exactly the same instance as before. So the fragment is the same one that we left. We return to the same instance, but somehow it restarts its lifecycle. And the fact that I want to stress here is that we should never, ever care or make assumptions on how the view will behave. Depending on the framework on how you use fragments or activities, the behavior can be different. How often it will be destroyed, the view, and recreated, we don't care. Our only job is to make sure it is lightweight enough so all the operations cannot be seen by the user when all these lifecycle functions are passed through, the view is recreated and whatnot. That's the only important thing here. Okay, and one little tidbit here is for this example, we need to pay attention to lifecycles because, as we see in the case of Jetpack navigation, when we observe live data and stuff, there can be weird behaviors. When I said we should never ever keep state in the view, this also includes live data observers because the view somehow has a reference to that lambda we're passing here for the observe function. And the implication that I was talking about before is we can deduce that we'll actually, in this case, register the same lambda, so the same observer, multiple times, and we'll observe it multiple times. Depending on the scenario and what we are doing in this observe function, this can have implications for what the user sees or not. But either way, it's not actually correct. Why is this happening? Because when the fragment, even though the fragment is not destroyed, it actually goes through some kind of configuration change from its point of view. It has multiple life cycles. It's created, resumed, and stopped when we leave it, and then it's again created from its perspective when we return. That's why, from its point of view, there are two completely different life cycles. But having the same instance of the fragment, it just held all the state the previous fragment, the previous iteration of the fragment had. I'm talking about that lambda again. So actually, we have two observers that are both called whenever the live data emits. Because if you want to take a look on the observe function in live data, it's pretty obvious why. It will actually check what lifecycle owner we passed, and if it sees it's actually two different life cycles, it will re-register that observer. So we just actually stored an instance to an observer for longer than the lifecycle it was bound to, and that's the idea I'm trying to pass, and we should never ever do. Fortunately, they made a fix after releasing Jetpack navigation, and they introduced a concept called the fragment view lifecycle that encompasses all of these smaller fragment life cycles. So it starts when the fragment is first created and instantiated, and ends when it is finally destroyed. So in this case, there's a very simple change we need to do in order for it to work correctly, and we are in sync. We can just replace the fragment owner with the view lifecycle owner, and we're done. But this leads to a very simple, mantra we need to follow when designing a view. It refers to what I've been blabbering on continuously. We should not care about when or how many times the view is created. It should be fast enough so the user doesn't see anything. I'm stressing this because even the upcoming view UI frameworks like Jetpack Compose will work identically. You should never ever care how many times the Jetpack Compose framework will render your UI. But let's not stop here. When talking about state, there are some additional errors out there that many of us do, and there are some actually simple fixes. There is a weird and thin line that splits responsibilities of the VMV model, and it seems that everyone seems to be playing around with it. That's fine for the large part. For me, I generally consider that the view model contains the current UI state, all the business logic along with its use cases, interactors, and whatnot, and all of our logic to make sure that we don't lose that state, even if the system desires to kill our process, because that can still happen. This leaves the view, in my perspective, with two simple chores: display whatever the view model says, and navigate wherever the view model says we should navigate to. So the user needs to see another view. Again, this is where I choose to draw this line, and it kind of works fine for me. But in the next slides, we'll keep focusing on that state, because talking about all of this will likely take more time. Let's take a simple example in which the view needs to display some items and the weird little label. For the rest of the presentation, I know we're going to see a lot of references to string, but keep in mind that this is about our resources in general. But it's only easier to describe everything with strings. So our first version uses a string to define this label. The view can simply place it wherever it decides. It just uses a text view in this scenario. But let's see what happens when we define this string. Let's consider that our little resource is defined differently depending on the device's configuration. In this case, we can take orientation. I know you guys know there are a lot of other configurations out there. Configuration changes, orientation is just a basic one. Without thinking, we inject our app context into the ViewModel because that's very easy. And we proceed to resolve the resource to its actual value. So what happens next? Now that I've been through this, I don't know, flow of thinking, I actually can't answer correctly the following question. What value does our string, some string, have right now? It does not have a value because the ViewModel does not know what the configuration change is because it survives it. From its point of view, some string may be either one of those values. So what happens next? We run our application, we execute the configuration change, and observe that something bad has happened. What do we do next? We just check the orientation to be plugged in portrait and mark that bug as complete. Kidding, never do that. If you analyze what we wrote, we can see that this is actually equivalent to a hard-coded string literal. This is what Android Studio bugs us about a lot. So it has the same values in multiple scenarios when it shouldn't. What I'm trying to say now is we should never ever evaluate any kind of resource because before it's actually needed by the view. Why? Because otherwise the view might have been recreated, I don't know, 3 times from the point the ViewModel resolved it and the moment the view actually needs to display it. So we have actually stored an incorrect piece of state that we now cannot use. It's not just this delimitation between the ViewModel and the view that the ViewModel holds the state, but it actually needs to hold the correct state. So we get smarter, we build version 2. We stop resolving the value in the ViewModel and we just specify the reference to the string we want to be displayed. But let's consider that a string may have arguments. I don't know, some strings have a lot of arguments. And shortly, our view gets more and more complicated and it's becoming very hard to maintain. I mean, changing one of this stuff in the future is going to introduce bugs, I'm sure of that. And then you say, enough is enough. You need a simpler way which you can accomplish whatever version 2 accomplished. You realize that all you needed all along was the ViewModel to somehow specify only the intention to use a string or resource. And it's not meant to be actually used until the view needs to use it. In case of strings, we'll build a better one. We'll call it strong because it's better. And what the strong needs to do is wrap around the resource, a resource identifier, and a variable number of arguments. They can either be a string or a strong, but for the simplicity of this example, we'll just mark them as any. We also want our API to be as simple as possible and as familiar as possible. So we're going to throw a bunch of extension methods because yeah, everyone loves extension methods. And we actually build the same signature as we have when resolving a string resource to a string. And then comes the interesting part. We need a way to resolve these strings on demand. This and one of the best methods we discovered is to do it recursively. Why? When the top level strong needs to get resolved, it tries to resolve its arguments, its parameters. We iterate through all these parameters. If this parameter is a strong in its turn, it would recursively go deeper and resolve its own parameters. So what we have actually done is built this tree structure of strongs that will only be evaluated when needed. And the advantage here is that you can build extremely complex pieces of text. For example, in our state version 3, we can just replace all of them with the strong, and we get back to the, I don't know, prettiness of version 1 and the functionality of version 2. Again, this is another thing I usually stress a lot about. We never forget about testing. We just throw this building of the strong in our use case because it can be easily mocked. And we're actually done. This is now another example of how easy it is now to build extremely complex pieces of text. You just replicate that tree structure in your strong instantiation. In this case, our label has an argument, but the argument has two arguments actually, but one argument has an argument in its term. It's extremely simple to specify everything, and we're now not resolving it when we shouldn't. Again, the view reaches the simplicity of the first version with the functionality of the second extremely ugly one. Next up, you're going to see that actually wrapping around resources, you can actually build like more complex scenarios. What we've done is went one step further, and we've defined several other types of strongs, like because we actually redefined what a spannable string means in our Android code and MVVM. You can define what it means to have bold or italic and have it on a piece of your text, or another piece of your text is colored with a different color. This has no limitations in this purpose, and because of the tree-like structure, you can actually now specify whatever you need and however you want it. Yeah, there's a bit of changes to the how strong is being built, but it doesn't get much more complicated than you've seen right now. And if you try to replicate the API we've been using until now, you're going to have an extremely easy time to use it further on, and it's very similar. And I guess that's all from us. Thank you very much for listening to us blabbering.
Yes, thank you also. If you have questions, please feel free to fill in your questions in the Q&A section, and we will be reading them out and hopefully answering them. If you all haven't fallen asleep since we started. Alex, I think you want to take the first question.
Have you thought about building a DSL for Strong? Well, Nishi, that's an extremely interesting proposition. I think that this is the only logical next step that you can do. No, we haven't. But it's really interesting. Is there a link to a repo with the example you showed? There is an internal repo. I don't know, Radu, do we have anything else than the internal repo? We're actually using all of this stuff I've been talking about. We can make a public one if anyone's interested.
We could make a public one with everything here. So just imagine that the things we discussed in this tech talk are gathered from multiple tech talks we've given in the past and presentations. So we have to actually bring them all together into a repo, but we could do that, yeah.
The interesting thing is we actively use this idea, all of these ideas, and they seem to work fine. And it's actually much easier to use a bunch of Android specific stuff for defining resources, like spannable string, ugly stuff like that.
Okay, then, so we seem to have answered the questions. Thank you all very much for attending. Hope you liked our presentation and hope you enjoyed Cognizant Cell Vision's Programmers Week. There's still 1.5 days left, so please be sure to register for all of the talks. There's also the women panel today. I think women panel today, and I think it's gonna be a very interesting talk. They're gonna go into a lot of interesting topics, so please be sure to register for that. Thank you very much. If you have any other questions for us, you can contact us at pw@softvision.com, so programmersweek@softvision.com. Send us any follow-on questions if you have. If not, thank you all very much, and we hope you have a wonderful day.